Hi everybody, Mr. Rubo here. Today we are talking topic 3.3 again, but this time we are focusing in on the quadrantal sine and cosine function values. Okay, so this kind of builds off a little bit of what we talked about in 3.2, which if we have our angle, we can draw a circle, and where it intersects will tell us this coordinate point. And again, we recall from 3.2 that cosine of theta is equal to x over r, and sine of theta is equal to y over r. Now, if we take those two equations and multiply both sides by r, we get what x and y equal. So if I multiply by r, those cancel, you get x equals r cosine theta. And then I do the same thing with the sine, right? And I can multiply both sides by r to cancel that out, and we get y is equal to r sine of theta. So that means the coordinate point for this point on the circle is always going to be r cosine of theta, because that's the x, and then r sine of theta, because that's the y. And so this is how we find points on a circle given the radius and an angle. Okay? So let's see a question where we're going to use it. And sometimes they won't tell us exactly what the angle is, so we just have to be careful here. So figure above shows a circle with a radius of 4, so that's important, along with the equilateral triangle PQR. Equilateral triangle. Going back to some geometry days. So which of the following gives us the coordinate point Q? So we're looking for this Q up here. So, well, we have the radius, but do we have the angle? Well, we do. They kind of gave it to us in a sneaky way by saying an equilateral triangle, right? So a couple properties of equilateral, all the sides are equal, but because it's a triangle, all the angles are then equal. Well, they would all be pi thirds. So they're all pi thirds, which is great. So this angle here is pi thirds. And because they are the same distance away from each other, like this, it's in this circle, that would mean that these two angles are also the same. So full thing is 1 pi, take away pi thirds, you get 2 pi thirds, split it in half means these two are pi thirds as well. Okay, so all of the parts of these angles are pi thirds. Okay, so now we're looking for point Q. Well, point Q is made up of this terminal side, which is length of 4, because it's a radius. And then the angle, so there's r equals 4. And then the angle is this pi thirds and this pi thirds, which means it's 2 pi thirds. So we look at our answer choices and we see, do we have one where the x coordinate, which is the one with cosine, and then the y coordinate is the one with sine, where the r is 4, and then the theta is 2 pi thirds. We just kind of go through the choices. For cosine pi thirds, almost there, but not quite. For cosine 5 pi sixths, not sixths, so we're okay there. Why does it do this? There we go. For cosine 2 pi thirds, that's good so far. For sine 2 pi thirds, there's our answer, right? And just to double check, hey, we have the right angles, but we have a negative r value, which does exist, but it wouldn't give us the right answer in this case. Okay, so yeah, there's our answer. It is C. So there you go. So yeah, they always have to tell you the radius and they have to tell you the angles, but sometimes, especially the angles, they may make you work for it. All right. So yeah, thanks for watching. Have a good day.